Day 21, page 622, problem 29. Here's the basic scenario. Three-dimensionally, basically what you'd have is like a floor and a ceiling as your parallel plates. This is the side view. You have a proton. You must have a positive charge plate at the bottom. That'd be like your floor, because that would repel the proton with a force upward, an electrical force upward. I'm going to call that F sub E. Electrical force upward, because gravity is pulling downward. That's the force of gravity, F sub G, or the weight. And what you want to do is you want to float this particle. You want F sub E to be equal to F sub G. It's fairly straightforward. You may need to look up the mass of the proton, which I'm forgetting off the top of my head. But bottom line is, once again, when you have parallel plates with a positive charge on the bottom, the field looks or goes this way from the bottom plate to top plate, or from positive to negative plate. So half the answer is the field is towards the ceiling, or up towards the sky, so to speak. And once again, like a lot of these problems, you have E equals F over Q, F being the electrical force F sub E. In other words, F sub E, electrical force, is EQ. And we're looking for E. So we're going to plug that in though. And we know force of gravity, F sub G, equals mass times gravitational acceleration constant. So if we plug those two values in, into the over here, you end up with EQ equals mg. And we're looking for E, the field that supports the proton. So E will be mg over Q. M, you look up at the mass of the proton. Gravity's acceleration constant is 9.81 meters per second squared. And Q is the charge of the electron, 1.60 times 10 to the negative 19th coulomb. So you plug those all in and you get the magnitude of the E field pointing upwards.